Right, for question 19, the last question is about something like curve, quadratic equation, and transformation of graph, completing a square, mixing together. It's very typical to see these questions in session B last question because they are more difficult and advanced. But for some basic fundamental questions, you should also know how to do it. For example, for part A, does the graph y equals fx open downward? Alright, so what does open downward mean? Open downward means like this shape. This shape means open downwards. So we need to know that whether so how do we determine whether it's open upward or downward? We need to look at the value of A. If A is positive, then it should open upward. If A is negative, then it should open downward. Alright, so let's see the value of A. Okay, so because the y-intercept is -12 provided. Okay, do you remember for testing about the quadratic equation, A, you can know the open, upward, or downward, and C, what does C tell us? Is the y-intercept. C is equal to the y-intercept. So from this question, we know that the y-intercept of the graph is -12 because y-intercept equals to -12. Therefore, we can immediately know C is equal to -12. All right. So we know that y equals to ax squared minus 4x minus 12. All right. So then we can also find a by using this clue, right? Substitute the point 79 into fx, right? So basically f7 equals to a7 squared minus 4 times 7 minus 12 equals to 9, right? All right, so 49a equals to 9 plus 12 plus 28, which is 49, so a equals to 1. All right, because a is larger than 0, because a is equal to 1, therefore we can prove that y equals to fx opens upward instead of downwards. Okay, so with the graph, we can arrive to a conclusion that the graph of y equal to fx does not open downwards. Okay. All right. So this is part A. For part B, you need to use the method of completing a square to find the coordinates of the question of the graph. This is a very typical question that must appear in session B, completing the square. All right. So do you still remember how to do the completing the square? But we first use back the equation, the function fx equals to x is 1, right? So it means x squared minus 4x minus 12. All right. Then we will do the complete the square. How do we do the complete the square? Recall. Okay, so it will be x squared minus 4x plus b over 2. Do you remember when we do completing the square? Not short revision here. Completing the square. Whenever you see ax squared plus bx plus c, then what you will do is firstly to pull the a out, right? A, and then so assume a is being pulled out already, then it will be a squared plus bx plus b over 2 squared minus b over 2 squared, then it will disappear, right? Then the whole thing makes sense, and this process is the completing the square process. Okay, so you need to show this step for a step mark for doing the completing the square. So what is b? Plus b, which is -4, plus b, which is -4 squared minus b over 2 squared, okay? Minus 12, continue, okay? So then you will arrive to the conclusion that x minus 2 squared minus this one basically is 4, so minus 16, right? So actually, you may wonder how you can obtain this. Well, you can observe the format, right? You can observe the format that a squared minus you can observe the format that a minus b squared equals to a squared minus 2ab plus b squared, right? This x will be regarded as a in this case. For this one, -4 over 2, which is -2, will be regarded as b in this case. So you can automatically use this identity to formulate that, oh, x minus 2 squared it is, okay? So you have completed the whole completed square process. Therefore, you can finally arrive to the conclusion that the coordinates of the vertex r. All right. The x is what? The y is what? 16, right? Negative 16, right? Because the y coordinate, you can see the outside one. This is the minimum value. All right. Or the maximum value. Okay. And then you can see the coordinates should be x minus 2 equals to 0, then x equals to 2. So the coordinates of the vertex is 2 and negative 16. Okay. So this is the end of part B. Alright, for part C, it is about transformation of function, the hardest part, S5 chapter 3. Alright, so let's see. The graph of y equal to gx is first step, reducing the graph of y equal to fx to h of the original along the y-axis. What does it mean? It means that along the y-axis means it is about vertical, along the y-axis vertical movement. So it should be gx equals to what? hfx. H is the factor, right? Okay, so it will be h equal to gx equal to h times fx. So you are reducing it, all right, to h, okay, along the y-axis, okay? And then for the second part, translate upwards. For upwards, it is just plus, right? You are moving up, so you just the whole function plus the number of plus the units, all right? So it is actually gx equals to fx plus c if it is moving upwards, all right? So just move upwards, which will be 1 minus 12h divided by 4h, okay? So after we know that, let's write down here hfx plus 1, okay? This is the movement of the function, the transformation of the function, all right? So the first step you need to do is transformation of the function. If you can do transformation of the function, the remaining left is just to solve it, okay? So gx, so what is gx? Gx is equal to h times fx, which is x squared minus 4x minus 12 plus 1 minus 12h divided by 4h, okay? So you build hx squared minus 4hx minus 12 plus, all right? So in this case, I will suggest you to isolate all the same degree into the same part, all right? So for example, with a degree 2, I can isolate it here, degree 1 here, then for remaining with the degrees, then let me use some manipulations. I can put this negative 12 into this times this 4h, which will be equal to negative 12h times 4h will be negative 48h squared, all right? This is gx, okay? This is the value. This is the function gx, okay? And then let's analyze about gx. What the question gives you about gx is that gx is always positive for all real values of x, okay? So we know that gx is always positive for all real values of x. And we know that h must be larger than 0 because h is a factor, right? A factor cannot shouldn't be a negative one. So h is larger than 0, and yeah, and provided by the question, right? And h is larger than 0. Therefore, what we can know is that the discriminant of gx equal to 0 is less than 0. Why? For example, if the graph is like this and it is always positive, then does it contact with the y-axis? No, there are no real roots, right? So the discriminant of gx is less than 0. This is the rationale behind, okay? No real roots, okay? For gx equal to 0, all right? So then we can use this to form a range of inequality, all right? So do you remember delta? Delta discriminant, b squared minus 4ac, right? b squared minus, okay, let me write the equation here again. Let me copy it here. All right, copy, and then I'll just, for time, so I'm saving the time. Yeah, all right. So, negative 4h squared, all right. Let me move it down. Oh, minus b squared minus 4ac. Okay, did I miss an h here? Yes, I missed an h here. All right. So minus 4ac is less than 0. Okay, delta less than 0. Okay. So simply solve this quadratic inequality. You can obtain that, yeah, this value. And then it's time to solve quadratic inequality again. So please note that quadratic inequality is a very hot topic and a useful tool for session B, okay? So when we solve quadratic inequality, do you remember how to solve? Is that you do something like this and then use a graph, okay? And then you can use first use the you do this analyze in your rough work. You can first use formula 0, 1, 64, 12 minus 1. So you can first obtain the first value is 0.0625 and negative 1 over 4. So it will be here 0. Okay, so it should be less than 0. Less than 0 meaning this part, right? So the answer of the solution for the inequality should be negative 1 over 4 larger than h larger than negative 1 over 4 larger than 0.0625. This is the first inequality form. And on the other hand, the question has actually provided that the range of h is 0 to 1 over 12. Okay, 0 larger than 1 over 12. Therefore, we can arrive to a conclusion that, all right, the range, you need to both satisfy, right? So it's an inequality, okay? So first one will be negative 1 over 4 to 0.0625, this range, okay? And the second range will be 0 to 1 over 12. 1 over 12 is actually 0.08333, okay? Second range will be like this, okay? And only the middle part, overlapping counts. Therefore, this range of h will be 0 to h to 0.0625. All right, this will be the solution for the whole question 19.